Okay, one more thing in this section, and this is looking at a couple of word problems. Okay, so as it states, you are painting a large wall mural. The wall length is 3 times the height. The area of the wall is 300 feet squared. What are the dimensions of the wall? Okay, so we're dealing with, obviously, a rectangular shape. All right, you're told that the length is 3 times the height, okay? So I'm just going to let X be the height of my wall. So the length of my wall has to be 3 times the height. So that would have to be 3X. So that's going to be the expressions that are going to represent your dimensions. Now you're told that the area of the wall is 300 feet squared. So we're dealing with the area of a rectangle. So you'll need to use your formula to find the area of a rectangle, which, as you know, is just length times width. And now we're going to substitute in what we have. So I know area is 300, length is 3x, and the width is just x. So 3x times x is just going to give me 3x squared, okay? Now, you need to solve this. This actually will go back to the first type of problem we talked about today, and that's going to be taking the square root of both sides. But before you can take square root of both sides, you need to divide both sides by the 3. So that would give you x squared is equal to 100. So now square root of x squared is x. Put your plus minus. Square root of 100 is 10. Now, since x represents the height of this wall, the height of this wall is not going to be negative 10. So when you're getting your dimensions, you're only going to consider the positive 10 in this situation. So the height, which is just x, that would be the positive 10. So the length is going to be 3x, so that means 3 times 10, which is going to give us 30. So 10 feet by 30 feet would be the dimensions for this wall. Okay, one other example. So again, you pause the video to take time to write down the word problem. A box is 4 inches high. Its length is 1.5 times the width. The volume of the box is 1,350 inches, and that should be cubed since we're talking about volume this time. What are the width and length of the box? Okay, so this time we're talking 3-dimensional object, and of course, as it says, we're dealing with a box. So let me sketch us off a box here real quick. I mean, I don't know if it's a nice cube or if it's rectangular, but that doesn't matter. Just to make us a box to have a visual picture is all we need to do. Okay, so here is my box. Now you're told that the box is 4 inches high. Now it doesn't matter which of the edges that you label, because you've got 4 edges that would represent the height. Of course, you've got from here to here, you've got the edge here on the front, this edge on the front, and you've got the one on the back, but I'm just going to label that one there. But they're all 4 of those edges would be 4 inches. Okay, you're told that its length is 1.5 times the width. Okay, so going back this way would represent the width. So I'm going to let that be x. So the length of the box, I'm going to label it down here, the length of the box is 1.5 times the width. So you're just going to multiply the 1.5 times the x. Now, that's similar to what we just did a few minutes ago, but I'm going to have to use a different formula this time because we're talking about volume of a box. Your volume of a box is length times width times height. Okay, we're told that our volume is 1,350. Our length is the 1.5x. The width is x. The height is 4. I meant to put a 4 there. Okay, so let's multiply the 1.5 times the 4. So that's going to give me 6. And the x times the x is x squared. Okay, so now we have an equation that's similar to the one we had just a few minutes ago. I'm going to be able to solve this by taking square root of both sides, but I would need to divide by the 6 first. So the 1,350 divided by 6 gives me 225. And now I'm ready to take square root of both sides. So square root of x squared is x. Square root of 225 is 15. That's a perfect square. And again, you're supposed to put your plus minus, but actually when I go to figure my answers here, I'm only going to consider the positive 15 because x represents the width of this box, and you're not going to have a negative width. So of course, we know the height that's 4. We just need to identify the width and the length. So the width is just x, which we said is the 15, so it'd be 15 inches. And the length is going to be 1.5 times the 15. So that's going to give us 22.5 inches. So there are your other two dimensions.